ELISA, which stands for Enzyme-Linked Immunosorbent Assay, is a laboratory technique used to detect and measure the presence of antigens, your target proteins, such as hormones, viral proteins, or other molecules, or antibodies in biological samples. Like other immunoassays, ELISA relies on the highly specific interactions between antibodies and antigens. The process begins with immobilizing the antibody or antigen on a solid surface. This can be done directly or via a capture antibody that is itself attached to the surface. The target antigen is then detected using a detection antibody conjugated to a molecule that enables measurement, often an enzyme that triggers a color change by converting a colorless substrate into a colored product. Let's look at the most common type of ELISA in more details: sandwich ELISA. ELISAs are typically performed on 96-well plates. The first step is coating, where antibodies are immobilized onto the plate surface. You might wonder how this works. Well, the plates are made of polystyrene, a hydrophobic material. Proteins like antibodies naturally stick to the surface through hydrophobic interactions, van der Waals forces, and some electrostatic interactions. Essentially, the antibodies cling to the plate like magnets. No chemical glue needed. This step is usually performed by the manufacturer if using a commercial kit. Once this step is complete, any excess antibodies are washed away using a wash solution. One method of washing is inversion and tapping. Plates are inverted to discard liquid and gently tapped on absorbent paper to remove residual droplets. After immobilization, a blocking solution containing proteins like DSA is added. This covers any empty spots on the plate to prevent nonspecific proteins from sticking during the assay. Again, during every step, there is a wash step to remove the excess. Next, the sample containing the target antigen is added. By specificity, the antigens bind to the immobilized antibodies, while other nonspecific proteins are washed away. Then, a secondary detection antibody, conjugated to an enzyme such as HRP, horseradish peroxidase, binds to the captured antigens. Excess detection antibody is washed off and a colorless substrate is added. The enzyme catalyzes a reaction that produces a color change, the intensity of which is measured with a spectrophotometer. The darker the color, the more antigen is present in the sample, and the lighter, the less there is, as the color intensity is directly proportional to the antigen concentration. And it's as simple as that. If you found this video helpful, please give it a thumbs up and subscribe to BioLabs for more tutorials on molecular biology techniques. And if you have any questions, please leave them in the comment section below and I'll be more than happy to help.